Let's go ahead and rationalize the denominator of this expression. So to rationalize the denominator means you don't want to have any radicals left in the bottom of the fraction because they are irrational expressions. So rationalize can also be thought of as getting rid of radicals. And the trick when you have two terms in the bottom is to multiply by what's called the conjugate. The conjugate of 5 root 11 minus 11 root 5 is 5 root 11 plus 11 root 5. So basically all you do is change the middle sign to its opposite and leave everything else the same. And that's what you want to multiply by. But of course, to keep the fraction balanced, you can't just multiply the bottom, you have to also multiply the top by the same thing. So I put parentheses around the binomials just to make sure that it's clear I'm multiplying by that whole entire expression, top and bottom. So the next step is to multiply it out. Before I do though, I want to show you a cool property on the side here. So what happens when you multiply the square root of 5 times the square root of 5? Well, we know the rule for radicals is you can multiply the inside parts together and keep the square root on. And again, this is multiply. So I would actually get the square root of 25. But the square root of 25 is, of course, just 5, right? So this is a property that's useful to know, that when you multiply the square root of something times itself, square root of anything times the square root of anything, you just get the inside part and the radical goes away. So we'll be using that today. Alright, so let's go ahead and FOIL out the top. 6 root 5 times 5 root 11 is 30 root 55. When I say root, I mean square root. 6 root 5 times 11 root 5, you do 6 times 11 is 66. But then you've got that property, root 5 times root 5 is just 5. So I'm just going to write it like that. And then on the inside, you can use that property again. 5 root 11 times 5 root 11 would be 25, and that's negative, times 11. And then last times last, we have negative 55 root 55. We also want to multiply the binomials on the denominator, and let's see what happens when you multiply by a conjugate. So 5 root 11 times 5 root 11 would be 25 times just 11 by our property. On the outside product, we would have 55 root 55. And then the inside product, though, would be negative 55 root 55. And that's what happens when you multiply by the conjugate. Notice that the middle two terms will be the same, except for with opposite signs, so they always cancel. And finally, last times last, minus 121 times just 5. Now if you look at what's left in the denominator, these are just regular integer numbers. There's no radicals left, and that was our goal. So the last part of this problem is simplifying. We can combine like terms in the top of the fraction. So we have 30 root 55 minus 55 root 55. Putting those together, I get negative 25 root 55. And then the middle part, 66 times 5 is actually 330. Oops. And then 25 times 11 is actually 275. So we'd have plus 330 minus 275, which comes out to 55 positive. And then in the denominator, 25 times 11 is 275, as we knew from before. And then also 121 times 5 is, we've got minus 605. So if you combine those bottom numbers, you get negative 330. Okay, well technically we've rationalized the denominator, but it's not fully simplified. The way you can tell that is if there's a common factor in these number parts on the numerator, then it may cancel possibly with the denominator. And it turns out that yes, indeed, there's a common factor of negative 5. Usually when the first term is negative, you factor out a negative, and then 25 and 55 are both divisible by 5. So if you wrote that as negative 5 factored out, you would get 5 root 55 minus 11. And then in the denominator you have negative 330. And so we can reduce the 5 on the top and the negative with the 330 and the negative on the bottom. And a little bit of calculation will show that 5 goes into 330 66 times. And the negatives cancel as well. So the way you'd want to write your final answer is actually 5 root 55 minus 11 all over 66. Ta-da! Hope that helps. Have a nice day.
Made with Doodlecast Pro.